We're going to transpose v equals the square root of t divided by m. So we're going to transpose for t in the first instant, and in the next, transpose for m. So let's rewrite the formula. V equals the square root of t over or divided by m. Notice that the square root symbol is over the entire quantity t divided by m. So the first thing we want to do is look at how all the variables are connected. And if you notice that t divided by m as a quantity has been square rooted. So in order for us to remove the square root that's affecting the quantity t divided by m, we will need to use the reverse of square root. Now, what is that? Square. So we're going to square both sides. So I'm going to square this side, and I'm going to also square this side. Now, when you square a square root, it cancels out. So what we have remaining is t divided by m. And over here, we'll have v squared. Now, of course, we can do this step, the next step, in several ways. All right. Now, we want to make t the subject. So I'm simply going to multiply both sides by what? Guess. Think about it. What am I going to multiply both sides by in order to make t the subject? If you said m, then that's correct. So multiply by m on this side and also multiply this side by m. Doesn't matter if I put the m after the v squared or before, because order of multiplication doesn't matter. And so this allows us to cancel the denominator m with the numerator m. And so what I have remaining on this side is simply t times 1, which is t. And 1 times 1 is 1, so t over 1 is simply t. And m times v squared is v squared m, or we can say mv squared. Swapping sides, we can just write the solution as this. Now what we could have done here when we reached this part, which was that's an alternative method, is this. I'm talking about when we reached v squared equals t over m. What we could have done was to put the 1 underneath v squared. So we have two fractions equal and multiply by numerator by denominator. So because we're trying to make t the subject, I'll just go with t first by saying t times 1 is t, put by the equal sign, and v squared times m is mv squared. And right away we find the solution. Now let's look at part 2, which is to make m the subject. So I'm going to write the formula again, t over m. And again, before we can actually get to t over m, we need to get rid of the square root. And so we're going to square both sides, which is the reverse of square root. And square cancels square root. And so we have v squared equals t over m. Now, of course, I think this method is much faster. So this is what I'm going to do. I'm going to put v squared over 1. So we have two fractions equal. And that allows me to multiply numerator by denominator. In other words, cross multiply. Now, since I'm trying to make m the subject, I'm going to go with m times v squared, which is mv squared. And then 1 times t, which is simply t. Now we have no denominators here, which is great, because we're now able to go right ahead and make m the subject. Now we look at how v squared is connected to m. V squared is connected to m by multiplication, because this is actually m times v squared. So to remove v squared, we use division. Now you recognize that, by now you should see that or recognize that once you have a product in the numerator, as in two quantities being multiplied, you can cancel out one of the numerators with the denominators as long as they have a common factor. So in this case, v squared and v squared, the highest common factor is v squared. And we're actually multiplying m by v squared. So long as we have multiplication in the numerator, as I said before, and we're dividing, we're able to cancel out. So v squared cancel out v squared. And so we have m equals, and we leave this as t over v squared, because these are unlike terms, so we cannot simplify. There's no common factor besides 1. So we have m equals t over v squared.